All right, take a minute and check me here. See how I did. And I honestly just kind of threw those up there haphazardly. Maybe I even put some mistakes up there hoping you'd catch them. What do you think? Zach, what you got? Yeah.
The first one of the ball one, what if that's directly positive?
Well, let's see. What's our positive direction? Up the hill, right? Is the ball going to be forced up the hill? The ball is going to be forced down the hill, right? So the ball is forced in the negative direction. So I think the acceleration is going to be negative. Liam.
On the last one, I kind of think it's like, I'm not sure if this is right, but the severe rodent one, so I've noticed the ball will hill, it's just going to come back down with gravity.
All right, this ball will eventually roll down the hill. That's good.
So won't the acceleration be negative?
Well, here's the thing. On this problem, what did we say was our positive direction? We said down the hill is our positive direction, right? So the force on the ball is going to push it down the hill. That's why the acceleration is positive. Right. What else? I must have made some mistakes, right? I mean, this is me we're talking about. Working on it. All right, I don't feel like waiting for Zach all of a sudden. I'm going to keep going. I don't know why. I don't know. Something just came over me. Forget about him. Now, here is where we put it all together. All right, here's where we can use the equations that we've written. And this is a tough problem to start out with. So just kind of watch the general strategy. Watch what we do here. Whenever we get this type of problem, step one is, I highly recommend sketching. So the boy's up on a balcony, 30 meters. There's my sketch. Here's my boy. You're my boy, Blue. You're hanging out over the balcony with your go-go gadget arm. You're going to throw a ball up in the air. You guys know what I'm talking about? Did you ever see Inspector Gadget? Is that still around? Huh, all right, good. There's hope for the future. And the boy throws the ball up at a speed of 25 meters per second. 50 miles an hour. It's a pretty good throw. Could be. How long until the ball lands? And now, I know what you're thinking. I am actually standing here telling you that I taught you how to solve this problem. Kind of. I gave you the tools, even if I didn't train you in using them. So that's what it's going to be about. That's why I said we're going to be spending a few weeks learning how to use these tools. Here's the idea, though. Maybe you guys can answer a few intermediate questions for me, and we'll get there. Let's do this. Let's write down our equation. X, as a function of time, is equal to the initial position plus the initial velocity times the time plus 1/2 at squared. How many of these things do I know? Do I know the initial position? That's right, good. Now, before we say yes, 30 meters, let's be very careful. Where is my origin here? Where's my reference point? Because I'll bet if I just had you guys decide, half of you guys, would say this is my starting point right here. I'm going to start where the ball starts. And the other half would say, I'm going to start at the bottom of the building, or the cliff, or whatever it is, the balcony. Right? Which one is the correct reference point? Or does it matter? It doesn't matter. You can use either one as your reference point. As long as you're consistent, you're going to get the right answer. All right? I'm going to choose this one. You probably want to too for now. All right? It's not that much tougher the other way. It's just, let's be on the same page. So this is my origin, and I'm going to say this is my positive x direction. So if all that's true, what is my initial position? That's right, I'm 30 meters above the ground, aren't I? Oh, the ball is. So 30 plus, what's my initial velocity? Do I know that? Good, it's in the problem. Initial speed of 25, so 25. Now, can I mess with your heads for a second? Positive or negative? A quick answer, be careful. Up is the positive direction. What direction is it moving? The initial velocity is up, right? Okay, so you're good. I'm just checking. Just want to make sure you weren't too hasty there. What about the acceleration? Do I know the acceleration? That's right. You know g. I'm going to do 10 meters per second squared times t squared. And I made a deadly error. Why is it negative? Gravity is going to force the ball downward. Right? So the acceleration is going to be negative. So here's where we're really doing applied math right now. This is Algebra 2, a fairly kind of middle-of-the-road Algebra 2 problem, but we have to actually use it and know how to use it. What else do I know? My question is how long until the ball lands, so what am I trying to find here? Time. I'm trying to solve this for t. Forgot a t right there, sorry. Do I know anything else? Do I know what the position is when it lands? Yeah. How high above the ground are you when you land? 0. All right? That's the point. So again, that's where it's tough. It's definitely applied math. You have to know, 0. And then I'm trying to solve. 0 is equal to 30 plus 25t, I'm letting the units go, minus 5t squared. Quad solve. Did I just hear a pouty sound? It's a quad solve. Come on now. Yeah, let's try and factor it. The first thing, if you're going to try and divide, and I'm going to divide everything by negative 5. And I get 0 is equal to, let's see, t squared minus 5t minus 6. Q. Right, just divided everything by negative 5. Does this factor? Try it. I'm looking for two numbers that when I multiply them, they give me negative 6, and when I add them, they give me negative 5. Plus, let's see, when I multiply them, I get negative 6, and when I add them, I get negative 5, so I'm going to go plus 1 minus 6. It works! So when I remember, we're not done. We have to figure out what t is. T is equal to -1 and +6. Go back to the problem. How long until the ball hits the ground? The ball hits the ground after -1 seconds. Does that make sense?
Yeah.
This is what we call a worthless solution. Extraneous solution. Has no physical meaning, right? Not really, anyway. But 6, a positive time, that does make sense, right? So yeah, Jessica's exactly right. The ball's going to take 6 seconds to hit the ground.
So then if you were supposedly to get like a positive x value, would that still just mean nothing? Or
Well, what you mean if you got 2 positive times?
yeah.
You would get 2 positive times if you were trying to figure out, say, if the physical situation dictated. So if I were trying to figure out when the ball was 10 meters above my head, I'd get 2 positive solutions.
And so that would be your answer with either what?
Yes.
Oh, because it's okay, yeah.
Once on the way up and once on the way down. For this one, there is only one physical solution. So mathematically, you're only going to get one physical solution. If you do it right, the math should always match the real world. Now, here's the deal, guys. We don't have time to work a bunch of different problems today. And that's probably